we are going to be doing proofs. We're going to be doing verification. So it is very important that you show all your steps. You're not allowed to do it in your head and say, oh, it just works. Like, you actually have to put on paper what you're thinking and show all your steps. So here's some guidelines, some ideas of when we do this, what you could try. So number one says work only one side of the equation. And we'll do this in just a second, but you see example one has two sides in the equation, a left side or a right side. You're going to choose which side you're going to work with and only do things on that side. You will never change the other side. It also suggests that you work on the harder side, the more complicated side. It would be more complicated if it has addition or subtraction. So looking at these two sides, which side do you think is more complicated? The left, right. So when we do this, we will be keeping the right side the way it is, and we will never touch the right side. We will only work with the left side. Here's some other ideas. Number two, look for opportunities to factor. We have reviewed factoring a few times in here, so look for opportunities to factor. You might need to find a common denominator. If you have fractions, add them together, subtract them. Look for identities from the stuff that we did last night, from last week, those identities, all those identities, substitute stuff. Pay attention to the other side, so we're not going to be doing anything with sin x, or sin squared x, but we still want to look at that every time to remember what we're trying to do. We're trying to get the left side to say sin squared x. That's what we're trying to do, so we want to keep that in mind the whole time. Number four, I've had to say a lot of times today, so remember this one. If you don't know what to do, maybe change everything you see into sines and cosines. So if you see tangent, make it sine over cosine. If you see cotangent, make it cosine over sine. If you see cosecant, make it 1 over sine. Change everything into just sine and cosine. That might help you. And then always try something. Here's your persevering. This is the persevering. It might get challenging, but you don't give up. You just try something. You might have to erase and try something new, but it's okay. That's why we're doing it in pencil. Should be. All right. What we are trying to do is we're trying to get the left side to say sin squared x by using all the things that we've learned in math. It is not okay, don't write what I'm about to write down. Don't write what I'm about to write down. It is not okay to say, oh yeah. Oops, sorry, that was awful there. It is not okay to just do this and not show all the steps on how you got there and say, oh, well, I did it in my head. That's not what we're doing. We are converting everything in our head to paper. It's like those proofs that you did in geometry where you show every single step. We do not have to write the properties, though. So make sure you are showing all of your steps. We've got 6 questions. I'm going to do the 6 questions in different ways so you see all kinds of different approaches. But you could totally do this differently than the way I've done it. So we're going to work on the left side, secant squared x minus 1 over secant squared x. Anytime you see like a minus 1, it's probably one of those Pythagorean identities. Do you have those handy or are they memorized? Sure. Let's do. They're memorized? Good. I'll be surprised if they are. What is secant squared x minus 1? So my first step is just changing the numerator to tangent squared x. And we need to get it to sine. So what else do they do? Secant is the reciprocal of cosine. So what do you want to do? You want to replace that with 1 over cosine? Or do you just want to move the secant to the top and make it cosine? I'll do the first way since you guys gave me weird looks on the second one. But if I'm dividing by a number, instead of dividing by the number, I could also multiply by the reciprocal. So I'm going to have tangent squared x multiplied by cosine squared x over 1.
Yeah, and then you divide cosine to get the sine for sine cosine, and that's tangent squared.
Tangent squared x is the same thing as sine squared x over cosine squared x. Divided by cosine squared x. They cancel. Marker's having problems today. And we get sine squared x. And that's what I wanted to get, so I know I'm done now. Yes.
So you say we write each step in words or just write?
Like this. I'm modeling exactly what I want to see. Okay. Again, there are different methods to approach these. You could have used the right side. It might be harder. But I'm going to do all 6 of these in specific ways so that you can see different ways to approach these. See if things to go off of when you do your assignment. All right, for this one, which side looks more complicated? The left side looks more complicated because there's fractions, and anytime you have addition or subtraction, it's more complicated. So the left side is the side I'm going to work with. So I'm going to leave 2 cosecant squared x as is. How can I add fractions? Common denominator. So when I look at these and I try to find a common denominator, they don't really have anything in common, so I just got to multiply by the other one. And remember, we multiply by a value of 1, so we multiply the top and the bottom. Okay, so there's 2 terms each. That means I'm going to have to FOIL the denominators. Numerator's easy though. But the denominator we're going to have to FOIL. Stop talking for a second so that you can FOIL the denominators.
Thank you.
You guys get it close? Sorry. The more you do these things, the more you'll start recognizing tricks and shortcuts a little bit easier. You never change the other side.
Oh man.
You only change one side. So you have to erase all that. Okay, so when we FOIL this out, we get 1 minus cosine squared x for both of them. And this should be something that you start recognizing. When you multiply a binomial that is exactly the same, except one's minus and one's plus, they're called conjugates. The center terms, the two middle terms, they always cancel out every single time. And this ends up being a difference of squares. 1 is a perfect square, cosine squared is perfect square, minus means difference of squares. So I didn't actually FOIL that because I already knew that it would end up that way, because I practiced and I recognized it. So if you recognize it, you can go straight there without actually having to FOIL and cancel middle terms. And then from here, we add together our numerators, and we get 2 over 1 minus cosine squared x. And then we go to our Pythagorean identities, because anytime you see like a 1 minus, there might be a Pythagorean identity involved. And is this one of them from that sheet? It is sine squared. So we take this and say it is 2 over sine squared x, which is the reciprocal of what we're trying to get. We're trying to get 2 cosecant x, right? So sine squared x is the reciprocal. So if I just move it up, then I will get 2 cosecant squared x. And then it is equal, and I am done. On which part? Where I got the 2?
No idea.
Okay. Is it this that I lost you on?
The one on top right there. No.
Lost me from like this step to this step.
Okay, this is one of our Pythagorean identities. Those 9.
And that equals sine squared x.
That equals sine squared x. So we'll just replace them. And then we moved it up. We use the reciprocal identity to move it up. So this is like over 1, but I'm not going to write it over 1. So I just moved the sign up and made it cosecant. Use the reciprocal. All right. This one, again, might be different ways of approaching it. I'm going to show you a specific way that I think might be helpful. These are 2 terms. Terms are separated by plus, oh, I'm sorry. Are we in agreement? We're going to the left side? Yeah. Okay. Forgot to ask that. We're going to keep it equal to 1 over there. We're not going to touch the side that has 1 on it. So these are 2 terms, and both of these terms have cotangent in them. So I'm going to factor out the cotangent from both terms. I'm going to undistribute it. When I factor that out, I'm left with secant squared x minus 1. And then I go and I look on my Pythagorean identities. And that is, what is it? Sorry, this marker is like writing very slowly. Yep. Because I forgot to write it. Oops. So then from here, cotangent is 1 over tangent. And those cancel. So factoring might be helpful. Next. I think both of them kind of look awful. I chose to work with the right side and keep the left side as is. But again, you could do it a different way. I'm just giving you suggestions that might help you in the future. So that's why I'm showing you it this way. What I want to tell you about the right side is that 2 cosine squared x is the same thing as cosine squared x plus cosine squared x. So 2 cosine squared x is the same thing as adding 2 of them together. That's what 2 means. And why I did that is because, boom, boom, cosine squared x minus 1 is the same thing as what? Negative sine squared. And that came from our Pythagorean identities, and you had to switch the signs, so you pull the negative out. And I'm done. I already equals it.
But you're giving us all this identity.
The 9.
Yeah.
The 9.
Like an example of each, right? You're not just giving us the, you know, we wrote it down, we wrote them down.
Yeah, the 9. That's what I'll give you. I'll give you just 9 of them listed. So you can do whatever you want. So you don't have to memorize them. But you should have what tangent is memorized. What's tangent? Sine or cosine. Like that you need to have memorized. Or sine is equal to 1 over cosecant. Those need to be memorized. But the 9 identities, you can just go ahead and have those.
It doesn't matter which side we change, right? Like
It does not matter which side you change.
It just has to be one side.
Just stay on one side the whole time. Yep. And you know what? You might start with one side and decide halfway through, I don't know what else to do. You erase and start over on the other side. Okay, this one. It is, generally it's more complicated if there's a plus or minus sign. So when I look at these two, I'm going to work with the right side and leave the left side as is. Now stay that one. And then on the right side, cosecant x, that is the same as 1 over sine x. And then from there, these are fractions. So in order to subtract them, we find a common denominator, which is sine x. So over here, I have to multiply this one by a value of 1. So it does not change the value of it, it just changes the appearance of it. We're multiplying by a value of 1. And then once I have common denominators, then I'll go ahead and subtract my numerators over the common denominator. And then I might look at my original left side and see, what am I trying to get to? Just keep reminding myself what I have to get to. 1 minus sine squared x, is that one of our Pythagorean identities? That one's cosine squared x. Again, what am I trying to get to? I need secant and I need tangent. But in the bottom.
Oh, cosine squared x is the same as cosine x times cosine x, so you're going to the cosine x over sine x as tan.
Okay, I'm going to repeat what you just said, so just in case it didn't pick up your voice. Cosine squared x is the same thing as cosine x times cosine x over sine x. And the reason why we chose to do that is because this is tangent. What?
The tangent was y over x.
Oh, I'm sorry, that's cotangent. So, you're right. So then we've got cosine x times cotangent x. What am I trying to get? Trying to get 1 over secant x tangent x. So you can just reciprocate both of them. 1 over cosine going down to the bottom becomes secant, and cotangent going down to the bottom becomes tangent. And we're done. See, it's super easy, right guys? I promise it does get better the more you do it, and it does become more fun when you understand it. which you're not gonna understand if you don't do the practice, so, but persevere through it. It is. That's exactly what I say. I feel like they're puzzles. And if you like factoring, this is kind of like factoring too, I feel. All right, this one again, you might try something totally different and be able to get to the same answer. I'm gonna suggest one method, but this is not the only method that ever was. Unfortunately, there's lots of different ways of doing things. I think the left side is a little bit more complicated than the right side because it has a fourth power. So we're going to leave the right side as is. We're going to work with the left side. And what the left side is it is subtraction. And the fourth power is just squared of the square. Squared, squared. So what we have is we have a difference of squares, which is factorable. Cosine squared x plus sine squared x multiplied by cosine squared x minus sine squared x. So that's factoring that I just did. I just factored it by using difference of squares. And then one of them is the Pythagorean identity. This one right here, that equals 1. And then that's what I'm trying to get to, so I'm done. If only the marker would write red today. So, like I said before, the universe does not reward people that do not work hard. So make sure you persevere through this. Try everything. And if you're not sure what to do, make everything cosine and sine. That would be the backup method if you're not sure what to do. And then I'm going to walk around and help you if you get stuck. The directions do say use a separate sheet of paper because you are not going to be able to fit it all on there. Make sure you get out a separate sheet of paper.